Alright, so now we're going to take a look at the ArrayList class. So unlike arrays, ArrayList objects, so these objects of this class, are going to automatically expand as items are added and shrink as items are removed. So one of the main problems that you'll run into when you're dealing with traditional arrays, everything that we've seen up to this point, is that once you set the size for it, when you initially construct it, or if you initialize the items and you specify what the size is meant to be, you cannot add more items to it or reduce the size of it. So whatever size you have, that's the size you're stuck with for as long as you're using that array object. But array list objects allow you to overcome this by expanding and shrinking based on the number of items that you've placed into them. Additionally, though, there is one constraint with how array list objects work, which is that they cannot consist of elements of primitive data types. For example, instead of using int, which would be the data type for primitive integers, you must instead use the class integer. So you've got the full word integer with a capital I. So to give you an example of this, we've got two things right here. One is that we're going to need an import statement. So in order to actually use the ArrayList class, we need to import that from the util package. Additionally, once we actually start declaring and constructing our ArrayList objects, we will use this somewhat peculiar syntax where we're going to specify that it's the ArrayList class. We then have a pair of these angular brackets, and then inside of those angular brackets is going to be the data type, specifically the class type, of the individual items of that array list. So in this particular case, we're creating an array list of integers. We're going to call it numList, and it's going to be equal to a new ArrayList object. Again, we're going to specify that it's going to be of integers, so we still have to use those angular brackets and the data type of the individual items. And then at the very end, we see the pair of parentheses to indicate that we are constructing this ArrayList object. So let's go ahead and go over to NetBeans and actually put this together. So we'll go ahead and create a new project, make a new Java application. So let's go ahead and call this one our ArrayList demo. Click finish. Go ahead and get rid of the extra comments. Clean up the style. So right above the class, we'll go ahead and do the import. So we're going to do import java.util.ArrayList. So we're going to go ahead and get the ArrayList class from the util package. We can then go ahead and create our array list right here. So we're going to do an array list. We have the angular brackets. So we'll do integer. We'll close that off. And then we'll go ahead and call this something like numList. And say this is equal to a new array list. And we'll go ahead and again specify that it will be of integers, and then that pair of parentheses for the constructor. So going through the entire thing, it's going to be the ArrayList class. Specifically, the individual items will be integers. We're calling it numList. We're going to assign to it a newly constructed ArrayList object of integers. And to make sure that we're actually specifying the constructor, we have that pair of parentheses at the end. So once we've constructed our array list, we can go ahead and start using the add method to add items to that array list, specifically to insert values at the end of the array list. So if we start off with nothing, when we use the add method, that's going to put an item, some value at position 0. When we use the add method again, it will put the next item or the next value at position 1. Use the add method again, and it'll put it at position 2. So in this example right here, we've created an array list of strings called nameList. It's going to be equal to a new array list object of strings. We have that pair of parentheses again to indicate that we are calling the constructor. We then use the add method 3 times, adding 3 different string literals to it. So we've got James, Catherine, and Bill. So that means that James will be at position 0, Catherine will be at position 1, and Bill will be at position 2. We can then use the for each loop. So just like we used it for our traditional arrays, we can actually use the for each loop for our array lists as well. to iterate over the names that were added to name list. So in this particular example, we're going to use a for each loop. So we're going to say for each string that we call name in our name list, we'll just go ahead and print that name to the console. Or you can actually just print the contents of the array list directly. So this is another advantage of the array list over traditional arrays. If you happened to try to print out the contents of an array by just putting the array itself into a print statement, you might have noticed that that does not come out quite the way you expect it to. But with an array list, you can actually do this, and it will just print out the individual items in that array list. So we'll take a look at both of these formats for our integer array list over here. So we've got our num list. So in order to use this, we'll go ahead and do our num list. We'll use the add method, and we can go ahead and add some numbers to it. So let's say that, again, similar to the very first setup that I did for my numbers array back at the beginning of this chapter, I did something to the effect of adding like 10, 20, and 30, so like 10 through 50. So we'll do something kind of like that here as well. So let's say I add the value 10. I'll then add the value 20, and then I'll add the value 30. So if I do something like this, 10 is going to be at position 0, 20 is going to be at position 1, and 30 is going to be at position 2. So then, if I use a for each loop, so we'll say for, let's say int, call this num in our num list. Then we can go ahead and do something like system.out.print our num. We'll go ahead and save that. And so then if we go ahead and run this, we can see the values 10, 20, and 30 printing to the console. Alternatively, if we want to just print out the contents of it directly, we can say system.out.println, and we can put in num list, like so. We'll then go ahead and run that, and that's going to give us our 10, 20, and 30. It'll do it as a comma-separated list, and we'll also have these brackets around it, so keep in mind precisely what that'll end up looking like if you choose to print it out directly like this. Additionally, we can use the remove method to remove an element at a specified position from an array list. All elements after that position are going to be shifted to eliminate any potential holes that this might have created in the array list. So to give you an example, we're going to say something like namelist.remove1. That's going to remove the name that was at position 1. So if we take another look at that one, at position 1, if we double check where we did our adds, we can see that Catherine was added at position 1. So that means that after we perform that remove, it's going to remove Catherine from that, and then it's going to shift Bill up to be at position 1 instead. So that means that after we've done the remove, James is at position 0, and Bill is at position 1. So it eliminates that potential hole that we might have created. Additionally, our add method can also optionally include a position to insert a value at a specific location in an array list. And just like with our remove method, we'll have to do a little bit of shifting. In this case, all elements at and after that position are going to be shifted. So in this case, they're going to be shifted in the other direction to make room for the item that you're trying to insert. So in this case, we're doing something like namelist.add. At position 1, we'll add Mary. So this is going to insert Mary at position 1. And then the value that was previously at position 1 is going to be shifted to position 2. So if we assume that we're doing this after we just did that remove method, so right now, again, looking at this array list that we have here, we have James at position 0, Bill at position 1. So now we're going to put Mary at position 1. So that means that we're going to have James at position 0, Mary at position 1, and then Bill is going to get shifted over back to position 2 where he originally was. The set method will essentially perform a removal and an addition all at once. So this is kind of useful if you want to just take those two lines of code that we just described, but kind of perform that action all in a single line of code. So the value at a specified position is just going to be changed to some specified value. So in this case, we're going to do namelist.set 2. So 2 is going to be the position, and then the string literal Jennifer. So this is going to change the value of position 2 to Jennifer. So again, if we use our example with all of the previous methods already having been executed on it, again, looking at this right here, so we know that we had James at position 0, Bill at position 1, and then, Mary at position 1, and then Bill at position 2. So now Bill is going to get essentially swapped out for Jennifer. So we have James at position 0, Mary at position 1, and Jennifer at position 2. So now we'll go ahead and take all of this and we'll apply this to our integer array list as well. So we'll go ahead and minimize this. We'll come over here. So right now we've got the values 10, 20, and 30. So let's say that before I actually print all of those contents out, I want to go ahead and rearrange this a little bit. So let's first start off by using the remove method. So we'll go ahead and do something like numList.remove. And let's go ahead and remove the item that is at position 1. So that's going to remove this 20. So if I go ahead and run this, we're going to see just 10 and 30. So now 10 is at position 0 and 30 is at position 1. Next, let's go ahead and use the add method with the position included. So we're going to do at position 1, let's put in the value, let's say 40 now. Go ahead and save that. So now it's going to move the 30 over so that it can put 40 in its place. So we're going to get 10 at position 0, 40 at position 1, and then that 30 at position 2. So you see right here, we've got 10, 40, 30, or with the entire array list, 10, 40, 30. And then finally, taking a look at the set method. So we're going to do numList.set, and we're going to do something like position 2, and we'll go ahead and change this one to 50. So now the 30 is going to get completely removed and replaced with that 50. So we're going to have 10, 40, 50. So we can run this, and we can see we've got 10, 40, and 50. And then one last method we can take a look at for the individual items of our array list is going to be the get method. So the get method is going to be used to access a specific element of an array list. So specifically, we can use that to get the value that is at the a certain position that we specify. So our example that we have right here, we've got namelist.get, and then we've specified position 1. So we're going to get the value of the element at position 1. So we can take a quick look at this, and we'll get into that size and capacity. So for this one, let's say right here. So right now I'm printing out all the items. Let's say in this other print statement, rather than printing out the entire num list, I just want to get a specific item inside of it. So I'm going to go ahead and use numList.get, and then I'm going to specify, let's say, position 0. So now I'm going to go ahead and get the item that is at position 0. So we still have it printed out right here, so we can see that 10 is going to be position 0. So now if I run this, on this very last line, we're just going to see the value 10, since we're getting just that single value from the array list. So the next method we'll take a look at is going to be the size method. So the array list size refers to the number of elements currently stored in the array list. So as you add or remove items from this array list, that size method is going to change. So if we take a look at this right here, let's say after we do this remove method, then the size of our array list will technically change. It's going to be a size of 2, so we can actually put a print statement right here. So we'll go ahead and say something like numList.size. Keep in mind that this is a method you have to call, so it's a little bit different from the array list's length field. So we'll go ahead and place one right there. So we should expect the value 2 to show up somewhere in our set of print statements. And then let's say at the very end we also go ahead and print out the size. So I'm just going to go ahead and grab this line, go ahead and copy that, and paste it right there as well. So then at the very end we can see the size again. By that point we've got another item added to it, so we should expect the size to be 3 by the very end of this program. So we go ahead and run this. So I'm moving this up a little bit. So right here we can see the value 2 at the very beginning, so that was before any of our other print statements. Then we see our 10, 40, 50, 10. So that's for the 3 times we print something here, the 10 that we print from this line, and then at the very end of the program, we can see the 3 for the size at this point. Additionally, there's also going to be the ArrayList Capacity, which refers to the maximum number of elements without having to increase the size of the array list. I will say now that in practical scenarios, the capacity is rarely ever going to be a concern. There's a lot of different methods whenever you call them that will automatically update whatever value this capacity holds. So it's very difficult to keep track of precisely what that number is going to be at any given moment in your program. But if you want to be able to access that, you can use this capacity method. So it looks pretty similar to the size method. Additionally, whenever you first construct your array list, you can specify the capacity on construction. So you can pass in a value inside of those parentheses. In this example at the very bottom here, we see that we are setting the capacity to 100. But again, I will say that as soon as you try to use some method like add or remove on this array list, there's a pretty good chance that that capacity is going to immediately and automatically be updated to some new value. So there's not really any way to control what the capacity is going to be in any practical sense. So the last thing I'll talk about for array lists, so in addition to seeing our integer example in our program, as well as that string example as we were going through the slides, I will also note that array lists of custom objects can be constructed. So again, if we recall the rectangle class that I used for a traditional array of objects, we could use that again for our array list. So I'll just briefly talk a little bit about what's going on here. The array list, again, we're going to specify that we are constructing an array list, or in this case declaring a variable for our array list. We're going to have that pair of angular brackets. Inside of those angular brackets, we're going to again specify the type of the individual items of the array list. In this case, the type is going to be rectangle, so we're going to put the rectangle class there. We'll then give it a name, something like rectangle list. We'll say that this is equal to a new array list object, angular brackets, so array list object of rectangles, and we're specifying that it's the constructor with the pair of parentheses at the very end. So similar to arrays of objects, the methods of the individual objects can be called. So once you've put this together, you could do something like getting a particular item at a particular position, so an object at a particular position of your rectangle list. So you do something like rectangle list dot get, maybe a position 0, so dot get 0, and then another dot, and then a method that you want to use on that that particular object that you've grabbed from the array list. One other thing I'll take a quick look at is going to be type inferencing. So array lists allow for type inferencing. This means that the data type of elements specified for the reference variable is going to be inferred when constructing the array list object. This is basically a fancy way of saying that you've already stated what the data type of the items is going to be whenever you were making your reference variable. So the only type of array list that that reference variable is going to be any good for is going to be an array list whose items match up with the variable's items. So because of this, you don't have to restate that data type in the constructor. Instead, you could have something like what we have right here. So if namelist is a reference variable for an array list that holds strings, then the array list object it references must hold strings. That part essentially becomes obvious at that point. So essentially what you have is you just remove the data type from the constructor portion of it. What you end up with is what is referred to as the diamond operator. Essentially you just have a pair of these angular brackets, so putting them together like that, it forms something that looks like the diamond shape. So that's where you get the name diamond operator from. So we can do this for our string, we can also do this for the rectangle, and to demonstrate this in our program, we come back over here right at the very beginning. So there's a warning that it's been giving us for this entire time, where it's trying to tell me that I have redundant type arguments in my new expression, and it actually explicitly says use the diamond operator instead. So it's actually talking about just getting rid of this part right here by just deleting all of that and leaving it with just this much. Okay, so at this point, this is going to wrap up everything for the ArrayList class and also finish up everything for going through all of the Chapter 7 content on arrays and array lists.